Welcome back to my channel. This is Steve's Trains at Top Shed 34A. Please like and subscribe to my channel. Steve here, welcome back to my channel. Bit of a different video today. As you can see, I use high-tech graphics and everything else in editing. No, I don't. I'm not that clever and never pretended to be. So I want to talk to you about something. The three different types of, I'll use the word point or turnout as they're known, and the different types of frogs, which is the crossing bit on a turnout. Actually, they're not frogs at all, they're called common crossing, that is the proper name for it. But for model railway toy trains, model railways, layouts, we'll just call it a frog because we all know what we're talking about. The reason I'm making this is because someone asked me today. I've always used Electrofrogs because they're better than Interrupts, which they are. And then someone asked me what Unifrogs were, and I thought, Unifrogs? WTF, what does that mean? So I decided to have a look at it, and I've come up with the fact that it's actually very cunning on behalf of Peco. But before we go ahead with that, let's discuss all these two, because the Unifrog is a combination of these two, and Peco's intention is to phase out this and that and just go with this, which will be good for a couple of reasons. One, means Peco will only have one set of type of turnouts to manufacture. Also, if you're a dealer, you've got to sell two types of point. You've got to sell live frogs, and how many do you buy? And they're all sitting on your shelf, and if they're not sold, they're costing you money. So it's also good for a dealer, because dealers will now, you go in there, that's all you'll get. So without further ado, let's get into what these are. So we'll do the first one. We're going to do Unifrog. So this is Unifrog. This is typical toy train track, whatever. So there's your stock rail, and there's we'll do like that. And then over here, you've got what was called a crossing V, or whatever, and then you've got like this. I won't show these touching, and like that. So this is the first type. This is what Hornby manufacture. With Hornby, all of this area here, where I've showed it in, they make that plastic. Now, so how they switch the track, so we'll just stick to convention, we'll make that positive and that negative. So that's always going to be positive, and that's negative, unless the train's going in the opposite direction, it doesn't matter. But so what they do, to switch the polarity, so that you actually, if a train's going straight, you want that to be positive, and if it's going around the curve, you want that to be negative. So this is switchable by these point blades. As these move over, as that moves over there, that becomes negative. And how does it get across there? Well, what they do underneath, you can have a look at these little points if you like. They put a little, I think it's a little strip. So underneath on the underside of the point, what they do is, I think they isolate them there. I can't remember. That's a long time since I've used one. So what they do is they put a wire, that's a piece of wire, and they go like that. And this one, this is to show it goes over the rail, it's not touching it, it goes like that. So when you switch that way, that becomes negative. When you switch that way, there's nothing there, and that becomes positive. So either one train will work or the other. And you think, great, what's wrong with that? Well, one of the problems with these, I mean, if you've got a long locomotive with loads of pickup, probably nothing. However, there is one problem. The contact between, to get power from one, was either made by these two rails touching like that, or what they used to do, I don't know if they still do it now, if that's a cross section of the rail, and there's your point blade, they will put a little tag like that. And so when it went under, that went underneath the rail and touched. But it relies on contact, it relies on the fact that there's no corrosion, and especially if you've ballast tracks, that was always a problem. So basically, that's explained to you what an Interrupted does. And I'm going to go on now and I'm going to show you why a Electrofrog is far superior. So Interrupted, sweet, it's done. So now let's look at Electrofrogs and why they were far superior, and they still are. If you look at a point, we'll have a look at it again. This is how an Electrofrog point is. It's really three parts. You've got that's a straight stock rail, the curved one, and then you had in the middle, you had this. I haven't drawn all the check rails and stuff up there, but anyway, there you go. So that'll keep you happy, right? So there, you've got three parts: part 1, part 2, and part 3. And as far as electrically, all of this was one piece electrically. So what was ever on there, if that was positive, the whole thing would be positive. The whole lot, that was all metal. Peco did, well, this is Peco, they did put an isolator in there. But what they did, this is on the Peco points at least, what they do is underneath, they put a little bond underneath. Just like that. All right, and if you turn a Peco point turn out upside down, you'll see that. Now, out the box, they will run fine. They got this. So basically, if I get that positive and that negative and that positive, sorry, and that's negative, sorry, that's negative. They'll always be that way. How these change will depend on how that is. So basically, what will happen is, if that's touching there, in other words, it's going straight, all of this will be positive, right up to there. All of that will be positive, and so would down there. So you'd have positive. You'd have a positive there, very close to that. Now, one of the problems is when a train goes past. I mean, we're talking toy trains here, right? I don't care how good they are. We're talking toy trains, right? And there's a lot of slopping wheels. If a wheel, you could get a point where a wheel goes past there, and that, through the wheel, shorts out with that. That will either cause arcing or stop your train, or in DCC, it might make the whole thing trip out. So that was one of the problems. The other problem, and this is something else to consider, well, perhaps we should go into this. Yeah, perhaps what I should say, I've got another piece of paper rustling. What I would say is you could use these straight out of the box, as is, just like that, but with a couple of provisos. And the provisos are this. If you had, say, well, no, I won't use a bit of paper. I'll just draw it up here, right? If that was just, I don't know, if that was just a siding like that, and you've got power there, here's your train there, whatever, right? And you've got power here, plus and minus. If they're just two sidings, you can put a train there and a train there, no big deal. But as I said, if that's going straight, there's a short here. If that's going that way, there's a short here. So one problem is, let's say you've got a simple train set out of a box. Well, actually, there's your oval of track, and you've got one siding, and you run your train round and round. This is with a live frog point. That works fine. Here's your power coming in there, right? where you run into problems, as soon as you decide to take that train into the siding and throw the switch, you've got a short on there which shorts out the whole power supply and your train stops. So the simplest way around that is very easy. All you've got to do is put an insulating fish plate there, or you don't even really need one there, but anyway, we'll put one there. That will stop that problem. But as it is, it's still relying on the contact between these two touching and this touching. And it's got the same problem as Interrupts. So the next step is how to wire these up so you actually switch the polarity of the frog. So getting back to it, we're still on the Electrofrog now. To make them operate better, here's what you do. And this is the way most people do it who use Electrofrog points. And it's more reliable, it is. So there's your point, and here's a bit like that. Oh, sorry, like that. Now I'll show it now. There's actually if you look at an Electrofrog point, you'll see there's little plastic pieces in there. So this is actually isolated away. If I get over that out the box, as I said, if you look at it, underneath, they put little straps underneath. When you wire these up, to solve a few problems, reliability, you cut these straps. And the reason you do it is because the first thing you do is you bond these underneath. You actually put solder pieces of wire across. So that is now positive. That is negative. All of that is positive, and all of that up to there. If you don't cut those straps, you'll have a short circuit. The power will go straight through there, down there, right? That solves the reliability problem. However, now, the other problem you've got is you've got no power to the frog. So, basically what you do, and it's not difficult, you can use Peco point motors or switching machines like Cobalt or Tortoise. They've all seat, but Cobalt ones and the Tortoise ones, they've got also sets of contacts, switching contacts. So, in other words, they've got a built-in changeover switch. Peco also make a little switch unit. You've probably seen it. I think it's called a PL13. It looks like that, and it's got two contacts. That goes through your point blade, and there's a single contact. There's a contact there, and if you put plus there and minus there, or minus there, depending on which way you switch it, that will be positive or negative. So you use this switch, and what you do is you take two wires. We'll take two wires there, and what you do is you take this third wire. So this switches depending on which way this is set. So it's positive or negative. You take that, and on the Peco switch, on the Peco Electrfrog turnouts, there's a little bit of wire, no insulation on it, just hanging down. Well, you just connect it to that. So, and you can only wire these one way. If it's wrong, if you've got a short circuit, you twist them around. It's either right or it's wrong. There's no other alternatives. So basically, that means you're providing power to the frog at whichever direction this point is. So it'll either be negative or positive, depending on which way you wired those around. You've still got the problem of a short here, so you've still got to put insulation fish plates on it. Now, it's always a good idea to do it because, well, if you've got a circle, you need it. Why would you want to do it in a siding? Well, there is a reason, and it's to do with DCC. In DC, not a problem. You don't have to use it. But what people use, I've got DCC, but I don't use lights or smoke or any of that stuff or sound, so it doesn't matter for me. But if this was, I don't know, let's say that's a platform. That's a main line. You isolate that because you'll put power to there. If it's DCC, you can put power to there. You don't have to. If you're just running trains on DCC with no lights or sound or smoke, you don't have to. But if you want power to it, you've then got to isolate that. So when it's straight, there's no short, and that way your DCC loco, this is a steam train, can be there with all its sounds, with smoke wafting out the... Do you like me smoke? Not very good, is it? Wafting out the chimney. As I said, if you don't have DC, if you don't have sound, you don't have to do that. Or coach lighting. Coach lighting will stay on. I'm not a big fan of that either. But it allows the coach lighting to stay on. So that is that's how we wire Electrfrogs. So we can check that one off. Is that good? You happy with that? Enter Unifrog. And I actually, seriously, I didn't know this till today, but I think it's pretty cunning. Because it means out of the box you've got a Unifrog point. If you want to wire it as Electrofrog, you can. It means Peco only has to make one set of points. The dealers don't have to have two sets of points. You don't want to go to the dealer and say, oh, I've got an Interrupted, and the dealer says, I've only got an Electrofrog. This way it's a win-win for everybody. So what have they done? I hope you like me. Tell me, listen, if you think the diagrams are crap, I know. Right? That's the same. So what they've done is this. Notice that's insulated there. I had to stop. My wife brought in tea, homemade pizza. Oh, delicious. So, what they've done, they've made this, as it stands at the box, this is really an Interrupted point. All that is isolated. So what they've done, they've solved the problem of a contact. This already comes pre-bonded. The other good thing is, unlike the old ones where you had a bit of rail and there was a bit of a knuckle joint, that's always going to be a bit of a dodgy area for electrical contact. They got rid of that, so this is now like the real railway. The rail actually flexes. So they've done that, that's bonding. What the other thing they've done, they've actually, so, where was I? Sorry, I got interrupted. So what they've done, that fixes that problem. So what they've done, with this means that now, this is always going to be positive. That's always going to be, I don't know why I do it that way. That's always going to be negative, that's always going to be positive, that's always going to be negative. Which is fantastic for DCC people. If it was analog, it means both of these are live. If that was a siding, it means you just got to put, I don't know, it means you'd have to put some sort of little gap there, an isolating switch. Otherwise your train will move like that. And how they do this is they bond. They put another bond in. They bond across that to that. So that's always negative. And similarly, they bond from there to there. That's what they do. Now, if you want, and that's fine with DCC, you don't have to do it. They're virtually live frog points. It's only the small tip which is not live. So again, if you want to make that live, you don't have to do this bonding. you don't have to put any insulating fish plates there or there on DCC. That's all gone. In fact, it's probably a step backwards for DC modelers, analog modelers, because it means that they've actually got to isolate the power. This used to, on a Unifrog point, sorry, on a Interrupted point, it was either one or the other. Now it's both. So again, all you've got to do is get one of those little silly little Peco switches. I don't know. You've got. We'll put them on both opposite sides. So you take one to there, and take this wire. As I said, there's on these new points. There's a wire hanging down, and you just hook that up to that, and that way, depending on which way these are switched, that's either positive or negative. So if it's wrong, if that's supposed to be positive and it's negative, it's simple to fix. You swap the two wires around. It's either right or wrong. There's no third choice. That's it. So, as I said, it's a good idea for Peco. It solves the problem. It just makes, the only thing what happens is if you're not interested in virtually what it means is if you've got an analog layout and you've got points going to, I don't know, like that. Say this is sidings. If you want to store a loco there, you've got a loco running there. You've got a loco there. As I see it, you turn the power on, they'll both operate. So what you're going to do is put a little switch, some sort of little switch in. I'm not going to make any judgment about if that's a dumb idea or not. I'm just telling you the way it is. So take it or leave it. But anyway, the fact is that Peco will gradually phase out Electrofrog and Interrupted, and they'll have one size fits all frog. Anyway, that's it from me. I hope you like the video. I do apologise for my lack of graphics. No, I don't. Or my fancy editing. No, I don't. I don't care. I just tell it as it is, pure and simple. Please leave a comment, subscribe and give us a like. Always like that. Thanks for watching.